Hello and welcome to ClearPix Cool Talks. I'm Marcel Lopez, a ClearPix BI consultant, and this is the inaugural video of our series where we go over various features of Microsoft Fabric. Today, we will be exploring directly and comparing it to a widely used import mode. But before we dive in, let's understand what Fabric is. Fabric stands as Microsoft's flagship of modern data platform. It shares the same interface as Power BI, making it simply accessible in Power BI-enabled environments. While Synapse is a PaaS, Fabric is a software as a service, SaaS, eliminating the need of managing different components with varying pricing in Azure. Instead, Fabric provides compute resources for all experiences from data factory, for ingestion and transformation, to data engineering, data science, data warehouse, real-time analytics, and even Power BI for data visualization. It offers scalability, allowing you to scale up, down, pause, and resume as needed. But which are the key functionalities we consider of Fabric? Well, first of all, it's all-in-one analytics solution. But what does it mean? Fabric encompasses data movement, data science, real-time analytics, and business intelligence within an unified platform. On the other hand, we have the one leg. It centralizes all data, eliminating the need of data movement across different experiences. And at last but not least, we have direct link mode in Power BI. It's a new method of connection to your semantic models that enables querying directly your data lake without any need of duplication or loading data in your model. This feature promises rapid reporting and extensive datasets. As you can see on the last part of this schema, this is what we are going to cover during this presentation. We will compare import mode against direct link. So now let's go and let's provide a brief overview of the three different available connections on Fabric to your data models. As you can see on this schema, here we have an overview of the three different available connections. First of all, we have direct query, which queries directly on the data source, such as your data warehouse. Then we have the efficient but latent import mode. The drawback of this mode is that it can lead to duplicate data across your different import modes. And the last one, and the newest, it's direct link. Direct link is a new feature of Fabric, allowing you to direct connect your models on your one link. So let's now compare all different methods. First of all, we have the engine, which is crucial to highlight that import mode and direct link uses the same Vertipack engine, and direct query uses the source as a system engine. The key difference between import and direct link is the storage. While direct link utilizes the same engine, it employs delta parquet tables on one lake for storage, contrasting with the internal compression used in import mode. This means that in order to your delta lake to work, you must ensure that your data is stored in this format. Then we have the refresh rate. Import requires scheduled data refreshes, where Power Query facilitates near real-time data updates and transforming DAX into SQL queries. Direct query employs a near real-time process that monitors and updates changes made to delta tables, offering the option to switch off the automatic refresh on direct link models. However, expertise may be required to optimize delta tables for better performance. In terms of data size capabilities, import imposes a strict size limitation of 1 GB, while direct link limitation depends on your Fabric subscription, potentially switching report to direct query if fallback thresholds are exceeded. And of course, we have the subscription mode. While import and direct query are available on Pro or Premium environment, to work with direct link mode, you will need Fabric workspace capacity. Now let's go to our use case and the demonstration. We'll compare the performance of import and direct link, focusing on use cases. For demonstration purposes, we'll use TPCH, a decision support benchmark database, querying the lines table, containing millions of order details. This database contains also other more complex data model, but for this use case, we are only going to query one specific table. As the tools that we are going to use for this test, we'll use Fabric Spark Auto-Managed Notebook to load our data into the workspace and the direct lake. We'll use, of course, a Fabric Lakehouse. To building the import report, we'll use Power BI Desktop. And then to track the query performance, we'll use SSMS and Server Profiler. The methodology we'll use to track the query performance of each of the models will be as the ones you can see on this scheme. We generated the same exact report using two different data models connections, and we analyze the performance metrics to ascertain the efficiency of each method, considering factors like query caching and data filtering. As you can see, on the import connection, we'll query directly the Vertipack model after the data model has been processed and imported. And for direct lake connection, we'll query directly or data lake without any need of model processing. Let's go now and let me show you how we did the performance test. Let me show you on this pre-recorded video how we did the test. First, let's take a look on the Lakehouse and see our data. As you can see in here, we have all our data entities that we loaded from this data warehouse for testing purposes. And on this demonstration, we are only going to use the line item table, which contains all the details from orders. As you can see, a preview in here. On the data lake, we can also check the background files that generate these tables. As you can see here, we have the Delta files that create a table. This is the system that enables the direct lake connection to automatically refresh the dataset using the log file in here. We can also see on our direct lake the Parquet files that we use to generate these Delta Parquet tables. Let's go back now and check our semantic models. Here you can see the SQL endpoint that our Lakehouse automatically generates to connect with the traditional connection methods as import and direct query. And in here we have the default semantic model that it's automatically generated, but in our demonstration we created two different semantic models containing only the line item table. On the first one, we have the direct lake connection. Let me open and show you the model and the different measures we created for the report. As this is a direct lake connection, we can edit and build the model directly on the service. For the import mode, we should build and design our model using Power BI Desktop and then upload it into the service. In here, we can see our table containing around 60 million rows. And we can also check in here the DAX measures we create to build our report that we will take a look in later. Of course, all changes that are done here are automatically applied to the direct mode model. And this is automatically going to our Delta files without the need of any load. Let's go to now and check our reports. We created exactly the same reports for direct lake and import mode. So let me show you the import mode report on the Power BI Desktop.
So here we have the report we are going to use to do the performance test. As you can see in here, we have an aggregation of the line items of the table with different measures like number of rows, total charge, the discount price, the quantity of lines, the extended price, the average quantity of lines per order, and the average discount. To do the performance test, we are going to do two different kind of queries. One without any filter, which will contain these 60 million rows, and one applying some filters to the query to see two different applications of the performance test. So now we will need to get the DAX query, and we are going to use SSMS to launch the queries directly to the service models and server profiler to check the performance and see how much time it takes to the model to process our query. First of all, to get this query, what we're going to do is use the performance analyzer of the Power BI desktop to get the DAX query. Of course, there are different methods to get this query, but we're going to use this one, and this is the easiest one. So we start the recording of the performance analyzer, and we refresh our visuals. Once this is done, we go to the table, and in here we can get the DAX query that it's being created by our report. So let's go now to SSMS, and I will show you how to launch this query, and then we will go to Server Profiler to see how we can track this query and see the time it takes to process. So in here, we can connect to our analysis service. In this case, we are going to use the analysis service connection to connect to the Power BI server. And the link or the connection you will need to connect to your Power BI server, you can get it in your workspace settings. You can get your link to connect your SSMS directly to your models. If you go to your premium section of the settings, this is the workspace connection you must use to connect to the server. In my case, I'm already connected. And now let's first launch the query into the import model. This is the DAX query that our report automatically generate, and this is the query we are going to track and analyze the performance. Before executing this query, we must first start the server profiler tracer. This is the server profiler. We create a new trace. We make sure that we connect to our desired model. And now we must also change the template of the events that are going to be tracked. Make sure that you select a standard. So this tool it's a tool that allows you to track all the events that are being launched to your data models. But in this case, we just want to track the DAX queries that are being launched and the duration it takes the model to execute these queries. So now we can start the recording. And we can go back to the SSMS to launch the query, and I will show you then these events and how to get the duration of the query. So now it's finished. These are the results. These are the same results that we had on our report, and we can go back to the server profiler. As you can see here, this generated the events on our model. So if you go right to the duration, this is the time it took our query to return results. As you can see here is the query end, and this is the query we launched from the SSMS. So in this execution, the query took 1,800 milliseconds. Okay, so now we will repeat this exercise, but connecting our model to the direct lake. We will go back to SSMS and copy this query, but this time we are going to execute it against the direct lake connection. As we did on the previous test, we must first connect and trace to our server. In this case, we will connect to the direct lake model. Remember to use the standard template to track your desired events, and we start the recording. So now we go back and execute the query against our direct lake model. As you can see here, we are having the same results that we had on the import model, and we go back to the tracer and check the query end event. So here we have the duration of the execution, and we are going to repeat several times this execution to get different test points, and we will compare it against the import mode connection. As we mentioned, we are going to realize two different kind of tests, one applying no filters and one applying some filters to the columns. We are going to do one final test with one special characteristic, which will be that we will refresh each model before doing the test. So the results are not going to contemplate any cache on the model. Let's go back and see our results.
After conducting multiple iterations of the same process, including one with model refresh to prevent query caching, we have the final results of our test. As you can see on this graph, while import exhibits superior performance, direct lake performs admirably considering the volume of data queried without the need of model processing. During test, we made two different benchmarks. First of all, applying no filters to the query and the report, and second one, applying specific filters to the data. As you can see, the results are pretty similar, and as we have seen on the last page, after the model refresh, query times increase widely. Let's go now with a wrap up and then conclusions. So Direct Lake proves invaluable in big data scenarios, offering rapid data access when leveraging a well-prepared data lake within a Fabric capacity. However, for typical scenarios where strategic data analysis does not require real-time updates and data can be aggregated to reduce data size of the model, import remains the best option. Ultimately, the decision to migrate existing import models to Direct Lake, in case you are thinking on migrating to Fabric Workspace and Fabric Platform, it depends on specific use case. Direct Lake excels in scenarios requiring analysis of large datasets or facilitating quickly data accessibility for experts within your organization, letting them access directly to your one lake without any need of processing data. On the other hand, import is perfect in scenarios where your data can fit into a model and you want to use all the capabilities of tabular, model, and DAX functions. There are some features that are still not available yet on Direct Lake mode. That's all from me. Thank you all for joining us on this session. We hope you find it insightful, and stay tuned for more cool talks.